Hi, my name is Chunglae. I'm OpenSON project manager, and this is YongYoon Shin. He's project source code committer, and this is SAEHOON, project architect. Okay, that's it. Okay, we'd like to introduce SDN-based approach for OpenStack networking, where a logically centralized SDN controller takes the role of the network node and manages networking services. Oh. I cannot go to the next. No. I cannot go to the next slide. Got it? Okay, let me continue.
Sorry, thanks. My Mac is
Okay, let me start with three motivations on why we choose SDN approach for OpenStack networking. The first motivation is from the well-known problem that network node is a centralized bottleneck point. For example, all inter-subnet traffic goes through the network node because L3 routing service is run on the network node. And all the external traffic goes through the network node because SNAT or DNAT services are run on the network node. So as the volume of traffic, such traffic increases, the network node becomes bottleneck point. Here. One of the solutions for this problem is to increase the number of network nodes and distribute the traffic load. But we still have another problem, which is the next motivation. The second motivation is about path optimality and path controllability. As you can see as you have seen in the previous slide, when two VMs are on the same host and they are in the different subnets, then the traffic between them still should go through the network node. And it causes unnecessary packet delay and triggers some extra traffic burden on the data network. So it wastes bandwidth resource. The third motivation is that the traditional OpenStack networking does not support network feasibility well enough. The network information OpenStack dashboard provides is limited to virtual network topology. It does not support more information, especially about the relationship between the virtual network and underlying physical network. We'd like to see more information, for example, for each VM, which compute node is hosting the VM, how the compute nodes are connected to each other, and what kinds of flows are currently active on the network or on a specific link. Here, we'd like to see more granular level of flows, such as VM to VM flows, not just compute node to compute node flows. And for each flow, which physical path is the flow using? For a VM to VM flow, we'd like to see the physical path from source VM to the destination VM on the underlying network. Considering these motivations, we choose SDN-based approach for OpenStack networking, where we remove network node and have SDN controller take the role of the network node, and it distributes the network services into the virtual switches at compute nodes by transforming the services into flow rules. By doing this way, we can remove the bottleneck point. This is our OpenSON-SDN architecture. In Neutron server, we put SDN plugin so that the SDN controller can receive event or request the messages for networking services and handles them properly using managers. We have ARP manager for ARP request handling, DHCP manager for DHCP request, L2 manager for virtual networks, L3 manager for virtual routers, SNAT or DNAT managers for SNAT, DNAT services. These managers install proper flow rules onto the OVS switches at compute nodes when they receive request messages related to their job. And we also have another modules for controlling and monitoring virtual flows. With Policy Manager, Flow to VNID Mapper, and Virtual Forwarding Manager, we can flexibly control the path for virtual flows. For example, we can use multiple paths between any two compute nodes, and we can use different paths for different virtual flows, or we can differentiate the quality of service for different flows. Now let's see how L3 networking works with SDN-based approach. When SDN controller receives the request messages for networking services, for example, virtual port creation for VMs, virtual router port creation, or floating IP setup, then the appropriate managers install proper flow rules on the OVS switches at compute nodes. For example, let's suppose VM1 and VM2 are created at compute node 1, and they are connected through a virtual router, and then proper flow rules for L3 routing are installed on OVS at compute node 1. Then the traffic between them does not go out of the compute node 1. And now let's suppose VM3 and VM4 are created at compute node 2, and VM1 tries to connect to the VM4, and through a virtual router. Then the proper L3 routing flow rules are installed on OVSs at compute node 1 and compute node 2. Then the traffic between them can use the optimal path between the two compute nodes. Now let's see, the virtual router is set up to connect to the external network, and VM3 is trying to access a server on the internet. Then proper flow rules for SNAT service are installed on OVS at compute node 2. Then the packets from VM3 destined for the external network are processed properly on OVS at compute node 2. And the packets directly go out to the external network. And DNAT case is similar. Now let me show you some brief demo video clips. Here, we'd like to show SNAT performance comparison between the two approaches. Left side is the OpenStack networking approach with a network node, and right side is the SDN-based approach. In each case, we have two VMs at different compute nodes, and they are trying to download data from servers on the internet at their fully available rate. And we set up the network bandwidth large enough such that the network node, such that the network itself cannot be a bottleneck. Then with the network node approach, okay. I got it. Okay, with the network node approach, you can see two VMs cannot use their fully available bandwidth. In this case, it's the compute node interface capacity. On the other hand, SDN-based approach, two VMs can use their fully available bandwidth. And this demo we can show that we can enhance the network visibility with SDN-based approach. For example, when we select two VMs, we can see the physical path between the two VMs. And the network, here the topological information not only contains the virtual network, and it also shows the underlying physical network. The SDN-based approach enables enhance the network visibility, and we can have some network applications such that network monitoring of virtual flows on the underlying physical network. Okay. So in this presentation, I'd briefly show that SDN-based approach for OpenStack networking, where we remove the network node and the SDN controller takes the role of the network node. It distributes network services over the virtual switches at compute node by transforming them into flow rules. The benefits are that we can enhance network performance and remove bottleneck point. And we can get optimality and controllability of forwarding path, and we can get better visibility on the network. Two institutions, S3 and Group Networks, are participating in this work, and these people are the main contributors. And in our OpenSON project, we also have been working on networking multiple OpenStack domains. We are looking forward to introducing this work in the next summit in Boston. And this is my presentation. Thanks for listening to my presentation. Thank you.